Picture this. It's 1926, a cold March afternoon in Massachusetts. Robert Goddard, the so-called father of modern rocketry, is in a field with a metal contraption that looks more like a plumbing experiment than a spaceship. He lights the fuse, people laugh, and yet, history says, that tiny launch began the space age. But here's where it gets interesting. Goddard had to carefully mix fuel with oxygen because fire on Earth in open air needs oxygen to even exist. No oxygen, no flame. Simple enough, right? Simple enough. Now fast forward. Every high school science class does the flame test. Copper burns green, sodium burns yellow. But the catch, every single time you need oxygen in the room. Take that same flame and seal it in a vacuum jar and boom, darkness. The flame dies instantly. Teachers call it basic chemistry. But then comes the question. If fire needs oxygen to burn here, how do rocket engines supposedly work in the vacuum of space, where oxygen is completely absent? They'll tell you rockets carry their own oxidizer. Sounds tidy. But wait, why do we never actually see demonstrations of that outside of CGI and animations? Isn't it strange that rockets here on Earth still release huge flames into open air, dancing and roaring with atmosphere all around them, while in space we're told they look like tiny flickers against total blackness? Why do the rules of chemistry suddenly shift? Imagine watching a campfire. It crackles, smokes and glows because oxygen feeds it. Now picture that campfire on the roof of a submarine underwater. Without oxygen, nothing happens. So shouldn't outer space, supposedly worse than underwater, snuff out combustion instantly, yet the narrative insists it doesn't? Curious, isn't it? The deeper you look, the more contradictions pop up. How do astronauts test rockets on Earth with massive plumes, then film them in orbit with barely a shimmer? Why do flame experiments here absolutely depend on oxygen, while rockets there don't? And here's the kicker. If the environment changes so drastically, shouldn't the visuals match? Shouldn't we see some kind of evidence beyond carefully controlled footage? So the story shifts. What starts as a basic chemistry rule in classrooms somehow bends when applied to space travel. Maybe it's all true, maybe it's all explainable, but doesn't it feel like there's a missing page in the manual, like we're being asked to accept two different sets of fire laws, depending on whether it's a school lab or the cosmos? In the end, the result is simple. We're left with a paradox. On Earth, flames beg for oxygen. In space, rockets supposedly laugh at that rule. And tucked in that paradox is a question no textbook seems eager to explore. If the ground beneath our feet is flat, curved, or something else entirely. Maybe the bigger mystery isn't the shape, but whether the fire we see is really what we're told it is. This video is for entertainment purposes.